We're here at the Wilsonville district event with Team 5468 Chaos Theory. Chaos Theory is in at their third event this season, coming home with 2 finalists awards at their previous events, the Canadian Pacific Regional and the Sundome district event. I'm here with Kevin, Max, and Owen. They're going to be talking about their electrical, mechanical, and programming, and talking about how reliable the robot is. Hear more on Behind the Bumpers.
This year we wanted to keep our robot rigid, reliable, and fast. So how we achieve that is by going with a belt and chain driven elevator. First stage is chain driven, second stage is belt driven. Along with that, it's a full width elevator, which is rigidly mounted to the base. We can go to high stow with the arm. The arm is a full composite construction using carbon fiber tubes and carbon fiber panels. Then with the end effector, we use belts to self-center. We wanted to give the human player as much wiggle room as possible. You'll notice the 2 Kraken X44s are mounted quite close to the axle. The reason for that is we wanted to keep the inertia quite close to the axle so we can spin it a lot faster. You'll notice here, these are our scrubber arms. These will remove the algae from the reef. We'll move them up and down real quick. They're mounted off-center from the manipulator, so they're perfectly in line with the algae on the reef. So after we do placement, we can directly go and remove an algae from the reef, so it's an integrated motion and we don't waste time on that. So you'll notice on the back of the robot, we have a climb. It was inspired by Rembrandt's. It has a part that flips out the bottom to engage with the bottom of the cage. It locks in with pins, it's spring-loaded, and the top is inspired by the EveryBot. We did stiffen it up by using some thicker polycarbonate because we noticed there's quite a lot of force on that barb. So we can extend climb here real quick. That engages with cage, and then we can lift up. So you'll notice at the bottom of the robot, we have a new system for our bumpers. We wanted to make them nice and rigid because we knew we were going to face a lot of defense this year. To hold them forward and back, we have pins. In every other dimension, they're held in place with miter rails. Keeps it nice and contained on all sides, and we can actually lift the robot up on its bumpers without anything bending. All right, I'm going to pass it off to Max to talk a little bit about our electrical.
Oh boy. All right, so I am this team's electrical lead. I just joined this year, actually. I don't really know exactly what to talk about, but I think one of the best things that we had to deal with, Marcel and I, this guy right here, was figuring out the best way to wire up the manipulator. So if you see right here, this carbon fiber tube, for one, it looks very, very pretty. And for two, it's a great way to actually protect your wiring. So what we had was all of our wires are coming up from this side here and going up. And then we have some sheathing here to just protect everything and make sure that it's all safe. And then we took some CNC chain from our CNC machine. Sorry, Kevin. And so that when we lift up the manipulator, it'll be guided really nicely. Could you actually do that real quick? Yeah.
All right, on that. All right, I'll forward.
Yeah, so if you take a look right here, you just see how nice and contained everything is. Everything is not shifting around. It's just really nice and straight so that we'll know where the wires are going to be so that they won't get hit and won't get damaged. But theoretically, at least, go ahead and bring it down. All right. And yeah, that was honestly my favorite part about wiring this whole thing and getting to deal with that. Another interesting concept that we had to play with was this part right here. All of our wiring for the manipulator is coming up and out into here. And so what we did was we had several iterations of figuring out the best way to actually get the wires in without them twisting or without them stripping on the inside of this. And yeah, I think that was just a really fun thing to experiment and play with. All right, Owen, would you like to go?
All right. Well, the next thing, I guess in our experience in 2023, which is the last placement game similar to this one, we realized that the hardest part for the drivers was lining up to place, getting exactly into the scoring position and not missing. And so we made accuracy and specifically a automated placement assistance during the teleout phase a priority for us. And so we have a handful of limelights on our robot for the positioning, so we can guarantee that our drivetrain is in the correct place. And then we have 2 reflectance sensors on the front and back of our manipulator here. These detect when we've picked up a coral. For example, in our auto won't drive off before we've properly obtained it. As well as each time we pick one up, it could be sticking out, so we back it up slowly until it loses the sensor, then back it forward slowly until it gets the sensor again, so that we get a nice consistent placement in the manipulator every time. We have a limit switch here because we noticed that this stretches, so we can't just drive back the motor a certain number of encoder rotations because this here stretches a little bit, so that can't really be trusted, so that's why we use the physical limit switch as our feedback for this climb system. And then for our actual auto align that we use to help the driver during teleop, we have we're using Path Planner for a lot of our automated movement. But we notice Path Planner has a on-the-fly feature where you can have it, automatically path finds to a certain pose. But we notice that can be inaccurate sometimes. And you can also do predefined paths, which have better accuracy, but are less flexible. And so the combination we decided upon was a mix of both of them, where our auto place, when the driver holds the placement button, it'll do an automated placement, an automated movement to the start of a predefined path. Also, the robot knows if it's the code divides the field into slices, like 6 slices. And if the robot is on one side, it knows what side of the reef is closest to it, because the field is like divided into slices like that. And so the code knows which side of the reef to auto align to. And then our second driver, our gunner, is the one who selects either left or right, and then the height of that placement on our elastic shuffleboard widget setup. And then also it's also aware of, based on what side it's on, based on what auto align side it's going to line up with. It knows whether the algae is going to be high or low. So we have a let's see. This algae, yes or no, is whether or not it'll scrub. Reef choice, yes or no. So we have our drivetrain simulated, so we can test things. But here, if the driver's on this side, I can just hold the button here. It will on the fly path to the position shown. And the way we select, A and B is the left and right. So if I have A selected, hold the button. And then this side is the side, so we have them numbered. Actually, here we go. We have the sides numbered. 1 is the one closest, 2, 3, 4, 5, 6. So like side 3, left. The driver holds the button and it aligns. We also have a mode where it senses which side to go to automatically. So this reef choice assist will move to whichever side is closest to us. It knows which segment of the field it's within. As well as L chooser is the height that we'll be selecting. And then the scrub chooser is whether or not to kick out our scrubber arms to knock off the algae. Yeah, that's about it. And all the alignment is done through Path Planner. Yeah.
Okay, so this is our pit slides this year. In 2023 at DCMP, I also made like a very simple Google slide to kind of show off our robot that year. But then the next year, which was last year, we had Hyperion, and I really wanted to make something that was a bit more impressive. So I decided to make kind of a 3D, almost like tour of the robot. And I did a very similar thing this year, where I took first this OBJ file from Onshape, and then bring it to Substance Painter, where I textured it, and then in Blender did all the rigging and animation. It's really nice to have in the pits as a almost presentation piece, and when people come by and scout, they see it and almost get an idea of how the robot scores and how it functions, because our intake is a little bit, sometimes it can be a little bit difficult to understand just by looking at it when you just swing by our pit.
Thank you, Team 5468. They're currently ranked #1 at this event and #1 EPA World, in Oregon. Thank you, team. Good luck at your competition today. And we'll see you at DCMP in a few weeks.